So welcome again to this training or this workshop on API security testing. As I said before, we try to see how we can seamlessly integrate API security testing within your existing toolchain. So we'll suppose that you have, let's say, integration testing or functional testing, etc. We'll see how we can build on top of these practices and existing tooling and process to inject or embed security testing. So again, this will be just an introduction to API security testing. As you may know, API or API security is complex topics, and there's a lot of aspect to cover, and it's completely impossible to cover all of these in a single workshop. But my goal or the challenge that I will try to achieve during this session is to provide you with the maximum information, with the useful information that you can directly reuse after this workshop, and let's say we'll give you some introduction and some basic information on how you can start, and from there you can go deeper and deeper if you want to enhance your security testing capabilities. So since it's a workshop, so we'll see a lot of demos, a lot of labs. So before the training, I guess you have received, or according to the training description, you need to have some tools installed already on your machine. But if you didn't have the time to do so, no worries. I will provide you with the lab environment ready to use. The only thing that you need to access this lab is to have just a web browser, and then you will have access to a sandbox that contains all the tools, all the materials that you will need in order to follow up and practice during this session. And we'll finish with some conclusions, and we'll try to open up the discussion and see your feedbacks and how we can integrate all of the tooling and the concepts that you will see together in this workshop. And I will basically also try to provide you with some common pitfalls and some mistakes that you need to avoid in case you want to integrate these tools within your organization, because this is something that I've been working on for almost 10 years. And when trying to embed security testing, it's not an easy task. So that's why I'll provide you with some pitfalls and some tricks to avoid in order to embed this security approaches or these new approaches seamlessly within your organization. So about myself, so my name is Abdessamad Temmar, but you can refer to me as Abdi, which is the short version. I work as an application security engineer, and I do also provide a lot of training. I am based in Paris, where I work for a financial company, but my roots are from Morocco. In the past, I used to work as an full-time pen tester. So if you know, this kind of title is where you come as a consultant or as an external consultant to perform security testing before deploying stuff to the production or before pushing new releases. So I was, let's say, on the offensive side. So my goal was only to point out errors and then provide developers with feedbacks in order to fix the issue that has been identified. But since 5 years, 5 years ago, I switched to a completely different roles. So now I work closely with DevOps teams and developers and QA testers in order to prevent from the beginning having this security issues that I used to detect as a penetration tester. So this way we can build secure application and push with confidence the new release and new changes to our clients. So this allow me to have or having this double background allow me to go deeper in the automation of security testing, but also understanding the constraints and the requirement of developers, which they have their own tools, their own process, their own deadlines. So it's important to have this double point of view in order to effectively integrate security testing into an existing toolchain. I am also founder of Keycloak Academy, which is an online platform that teach about a solution called Keycloak, which is an identity and access management solution. This is something that I also work with my developer teams. So the goal is to use this solution in order to have a central point that manage identity, but also authorization for all the application within our organization. I also had a chance to contribute to the OWASP community, which is the Open Worldwide Application Security Program. So this program is open organization that with one single goal is to provide developers with tools, guidelines, and resources to secure their application. So we have many projects and guidelines that are available. The famous one is the OWASP Top 10 risk for web application, but we also have one for API and mobile application. And we have many different tools that can be used to scan your projects and secure your application. So if you don't have a chance to check the tools from this organization, you can check their website. It's the OWASP.org. And from there, you will see a bunch of useful resources that you can use within your existing job as a developer or as a QA tester. I also had a chance to speak to different conferences. So as an application security engineer, mainly I speak into hacking and security conferences, but I try sometimes to apply also for dev and testing conferences like hands-on testing, for example, in order to get in touch with developers and with the dev community to have their feedback, because it's really important to consider their opinions and also their constraints. This way we can build up something that satisfy both party, because from the security perspective, we always want things to be secured, and we also have our own, let's say, requirements to fulfill. But it's also important to consider the developer and the QA tester perspective, because this way we can came out with a solution that work out for both parties. So after this introduction, I will move to the agenda of this workshop. So I will try to provide a light format, so this way we can respect the time slots available for this session. So first, I will try to explain the manual approach, how we can do application security testing as a penetration tester or as a security analyst. So the input here is the API definition or the API target that we want to assess. And then we perform some security checks, which are a combination of manual testing and semi-automated testing. And the result would be a security report that contains the list of vulnerability that need to be fixed. So this process is a time-consuming process, and sometimes it requires many days depending how many URLs we need to test, and also the number of profiles, etc. So I will try just to give an introduction on how we can achieve this. I will talk about the tools, the guidelines that we can use to effectively test an API. And then we'll see how we can automate this process, because let's suppose that your organization have to push releases every week or every month or every semester. Depending on the size of your company, you cannot do manual security testing each time. This will create a bottleneck for dev team, and it will also slow down the process. So we'll see how we can automate at least the most important checks and embed them along with our existing workflow and process. And then we'll finish with the conclusion. And the goal here is to discuss the limitation of the automation, automated testing, and also the benefits. And I will also open up the discussion if you have any question on the stuff that we'll discover today in this session. So that's it for the agenda. So please don't hesitate if you have questions. I will try to keep an eye on the chat. Otherwise, I will answer all the questions at the end of the session. So also, if you want to enable your microphone and take on the stage and ask your question, feel free to do so. I want this to be an interactive session, so this way I can provide you with the thing that you want to have during this this workshop. Perfect. So as I said, we'll start first by exploring the API security testing and how it can be done, okay? So for the manual approach and from a penetration tester point of view, there are some steps that we need to follow in order to assess the security of an API. And each penetration tester has its own methodology, but it always comes to these three main steps or three main stages. And so I will try to explain each one, and also the example of vulnerability that we need to check, and the setup required in order to test an API security. So the first step is what we call the reconnaissance. Then we have endpoint analysis, and the third step is exploits the issue and the vulnerability in the API. So depending on the type of the engagements, as a penetration tester, usually we have two types of assessments. So the first one is what we call black box testing. The second is white box testing. So the difference between the two testing approach is that the first one, we have almost zero information about our target. So we don't have any clue about the target that we want to test. The only information that we have is, for example, the name of the API, or at least the URL, okay? So here, for example, we only have the URL or the root URL of the API that we want to test. Okay, the second approach is completely different. Here we have full knowledge of the API that we want to test. So basically we have the API definition, like the Swagger files. We also have some Postman collection in order to test the API and play with it. We have the source code. We have all the necessary information regarding this API. And in terms of results, this approach usually allow us to detect more issues, because let's suppose you start black box testing and we didn't manage to identify the entry point and the different URLs. At the end of the assessment, we will almost have no issue or no vulnerabilities to report. But with the white box testing, and since we have all the information that we need, we can this will allow us to in terms of coverage, we will be able to cover all the endpoints related to this API, and in terms of results, they'll we will have a big chance to detect and exploit vulnerabilities. So here I'm always speaking as a penetration tester. So the second difference between the two is this one require a lot of times, because since we don't have any information, we need to collect the maximum information about this target API. So that's why we have the reconnaissance phase. So the reconnaissance phase, the goal is to collect and identify all the information related to our API. So, and the approach can be different regarding the, or depending on the type of test. So if I'm doing a black box testing, I need to do some intels like searching in public documentation, searching on public GitHub, and see if there is any leaked information about this API, if it's private one. And if it's a public API, I will just check the online documentation, and this way I have the information that I need in order to continue with the following steps. So here the goal again is to collect the API definition, calls, API calls, also the technology used. Was it built using Spring? Was it built using Express, etc., etc.? So all this information allow me to move on to the next step, which is the endpoint analysis. So the endpoint analysis, this involves examining the HTTP and the HTTP request and response sent back by our API. Okay, so this allows us to, for example, identify what type of data are sent, what type of functionalities, is there any leaked secret information inside this API? Is there something that we are not supposed to see or use as an anonymous user or as a simple user, etc., etc. So here, the outcomes of this step, we have a list of potential issues that we need to target later on the third step. Okay. So I will give just a basic example. So let's suppose that we, during the endpoint analysis, we have identified an API that search inside the database. So in the exploit and on step, we'll try to see if we can abuse this form, for example, to access data that belong to other users, or exploit maybe a SQL injection in order to extract all the database. So this is the kind of stuff we can test during this step. Okay, so this is the general approach. But if we want to be sure that we cover everything during the endpoint analysis step, we have many guidelines that can be used as a reference in order to make sure that we don't miss out anything important. So here I have a list from the OWASP top 10 risk. OWASP top 10 risk for API. Okay, so this document contains the list of the top 10 risks that that are common for API. Okay, so this is something that I cannot miss out as a penetration tester or as a security analysis. I definitely need to check if my API, depending on its nature, if is vulnerable or not to this top 10 risk. Of course, there is more than top 10 than this top 10, but it will be a shame if I push to the production or release a new version of my API and it's vulnerable to some of these issues. Okay, so that's why we have this document. So at least these 10 common issues or risk are covered during our security process or even during our assessment. So here I have, we won't go through the details. This is not the goal of this training, but in a nutshell, we check if we can do some injection. We analyze the authentication process. We see if the API doesn't leak any sensitive information. Some other important aspect is the access control. For example, we check if a user is restricted only to his scope, or maybe he can abuse other functionality and access data that belong to other users. We also check the functionalities. For example, if the API related to the admin area are only restricted to privileged user. So this is some example of the thing that we check, and also the misconfiguration. So let's suppose that from the source code perspective, we done everything to secure our API. We have correct authentication, we have secure access control, but let's suppose that you store your session on Redis Redis database with a default credential, or you expose this database and inside an attacker might find tokens or sensitive information that can allow him later on to have access to users' data. So this is not something that is not related to the application itself or the source code of the application, but it's related to the environment and its configuration. So it's important to not only cover the vulnerability related to the application level, but also the environment that is used to host the application. So this is briefly the kind of thing we test, but if you want to make sure that we cover all the aspect related to API security, we have a nice document called the OWASP Application Security Verification Standard. So the aim of this document is to provide testers, developers, and also architects, etc., with the list of steps or verification that you need to go through in order to validate the security of your web application or your API. So this is a general document about software security. Okay, but we have dedicated sessions, for example, for mobile, for API. And in fact, we have detailed section about API and web services. So you have a dedicated section for RESTful API, SOAP, GraphQL, etc. So for each section, you have the list of things that you need to verify, okay, with the description and also the corresponding details on how to check it. Okay, so using this resource, I can make sure that during the endpoint analysis, which is a crucial step, if I have go through all the necessary checks and then exploit them during the last step. Okay, so this is basically how the general approach and also the list of controls, or let's say requirements, that we need to validate in our API from a security perspective. So we have different resources. Now we'll talk about the setup, how we can go through all these controls that we mentioned, for example, on the ESVS. Okay, I want to check the authentication, the access control. What are the tools that that are available in order to test all of these controls? So this is a classic and basic setup of for someone who want to perform security testing for an API. So the first thing is, of course, we have the API that we want to test and the clients that consume the different endpoints available and exposed by our API. So these clients can be either a web browser. Okay, so let's suppose that we have an Angular application, any front.js application that consume this API. So the client would be here is a browser, but as you all agree, we also test or access API using a client like Postman, Insomnia, etc., etc. Okay. So as a penetration tester, I need to proxify all the traffic between these clients and the target API to a local proxy. So this proxy is an attacking proxy that will allow me to examine the traffic that between the clients that consume the API and the API itself. So this way I can observe the traffic, I can analyze the HTTP request and response, and from there try to identify and test all the requirement and the verification that I have in this document. Okay, so let's see exactly how it looks like. I'm going to switch to my burp tool deck. So so here I have the proxy that I mentioned on this step. Sorry, on this slide. So burst speed is a proxy, a local proxy that can be used to intercept the traffic between the clients and the target API. So I will not go through the detail of this tool and how it works and the different menu. We have different functionalities that we can see here. So Burp Suite is, we have two editions. We have the community edition and we have the professional edition. The community edition is available for free. And the main difference between the community edition and the professional is the professional comes with additional functionality like the automated scans, like access to the support, etc., etc. So for the ISVS, I will put the link on the chat. And also the link to Burp Community Edition. So the Burp Community Edition, I believe it has all the necessary functionalities if you want to manually test your API, but if you want to automate the testing, unfortunately, it's only available on the professional version. Okay, so here I have the professional version, but on the upcoming labs, we'll talk about another tool which is quite similar, which is fully open source. It's called Zaproxy. And this is the one that we will use in order to demonstrate how to automate security testing. Okay, so let's go back to Burp Suite. So here we have different menu that can be used to analyze and test our target web application or API. The one that we'll be focusing on during this demo is the proxy tab. So here I have the ability to intercept the traffic. So first thing I need to do is to have a client that will be used to consume the API. Okay, so let's suppose that the client is an Angular or a JavaScript application like this one. Okay, so if you check the network tab, you will see some traffic going on to uh, our target. Okay, so here I can see the request and the HTTP response. Okay, but my goal here is to proxify this traffic to my proxy tool. So if I go back to Burp Suite, here I have my client and here I have my proxy. So in the HTTP history, I have all the HTTP requests sent and the response received from this target API. So here you can see that we are calling an API which is under API cybercops .mr, and we can see on the same time the same information that we have on the network. The interesting thing about this is we can not only view the traffic, but we can also replay it and play with it. So we have a second model, which is the repeater, that can be used to replay and mess around with this, with all these requests. Okay, so I will talk on this later on, but if I want to follow the steps that we explained and so on the previous slide, the first one is the reconnaissance. Okay, again, the goal here is to identify all the URLs, all the API calls related to the target that we want to assess. Okay, so in order to achieve this, if we are using a JavaScript application, as a penetration tester, I will try to navigate through all the functionalities of this application. Okay, so this way I will trigger all the API that are used by this Java application. So I'm trying to reverse the the application in order to determine what are the API that are used by this application. Okay, so here I can continue by going on through all the functionalities, but it's important to, as a penetration tester, to take as much uh, to take time as much as possible before moving on to the analysis part. Because if we miss an endpoint and we don't map it to our proxy tool, maybe we will miss some vulnerabilities related to this specific endpoint. Okay, so depending on the size of the application, of course, I will spend more time on this first step. But now I will move on to the next step, which is the endpoint analysis. So again, the goal here is to identify and analyze the HTTP requests and responses in order to identify potential issue that I can exploit later on the third step. So here, if I go back to Burp in the history, as you can see, I have managed to collect many HTTP call. Okay, the same information that I have here. Okay, but I have another interesting view, which is under targets, and here I can view the structure of this this API. Okay, so here I have all the API that has been called. Okay, and that I can use later on to do my security assessment. Okay, so let's suppose now that I have all the necessary HTTP calls. The next step will be to do the assessment. So I need a way to play around with this HTTP call. So that's why we have again the repeater menu. So here I have, if I pick up a random HTTP request, I can send it to the repeater. Okay, and from here I can manipulate and change any parameter I want in order to test the security of my API. So for example, if I want to test SQL injection, I can input or use this input, for example, to, I need to analyze this input by injecting special chars or things that are not expected for the application. And based on the response, I will be able to determine if this API is vulnerable or not. Okay, so from here, I need to go back to the ISVS, okay, and check the list of control that I need to carry out in order to test each endpoint. Okay, so again, this session, it's not about how to identify manually security issues. The goal is to see how we can automate this whole process. So as you can see, there is a lot of steps that we need to go through in order to just for the first um, uh, major steps, which are the reconnaissance and also the analysis. We didn't talk about the exploitation, which can take more time depending on the size of the application. So all of the things that we done so far are manual actions. So I need to browse the web application. I need to test all the functionalities, send it to the proxy, and from the proxy or the burp tool, I need to analyze each request and go through the ISVS list of controls and be sure that I didn't miss out anything important. So this is, as you may, I think we all agree that this is a time-consuming issue, and we cannot do it each time we have, for example, a new release or a new application. Second way in order to analyze an API is how to interact with an API is through a Postman collection. I will finish by this before moving on to the automation um, uh, step. So here, for example, so first we talk about how to gather all these HTTP calls, which is the entry point. It's very important. If we don't have these HTTP calls and the responses, we cannot start the assessments. So that's why I'm taking too much time on this one. And the first way is to use the Front.js application. But if we do have the Postman collection with all the API calls or examples to use this API can be much faster because here we can just execute the Postman collection using Newman, or maybe if you want, you can go through all the API one by one. So here it's a completely different way to interact with our API, but the results is almost the same. So again, I have my Postman, and in order to proxify all the traffic to my proxy, I need to change the setting and go through proxy, and here I'm using burp, which is listening on this port. So you can find out which ports your burp is listening on under this menu, which is proxy settings. So here I have my proxy listening on this IP address and ports. So I need to input the same one here in Postman in order to be able to send all the traffic to Burp. So once our proxy is configured, we can all the requests will be sent first to our proxy before going to the API. So here I'm just going to test, for example, the login request. If I click on send and go back again to Burp, we will see that we have the HTTP request sent by Postman and the response that has been sent back from the API. Last thing before we move on is here we have disabled the intercept. We can proxify the traffic, but here the interception was off. So this means that, but when I enable it back by putting intercept is on, if I send the new requests, it will appear here on Burp. So I can play with the request, change it, okay, and then send it back. And I can also intercept the response. So let's suppose that the response received from the server is this one. I can edit the response and play with what the backend sent to Burp before it goes back to the Postman interface. Okay. So to sum up, we have three main steps: reconnaissance, endpoint analysis, and finally exploitation. For the reconnaissance, we need to proxify all the traffic that comes from the clients that consume the API. It can be either a web browser, heavy client, an application testing like Postman, etc. Once we have traffic inside our Burp suite, okay, we can start the analysis and determine if we have any security issue by following this guideline, for example, which is the ISVS. We have other testing checklists, but mainly this one is the most accurate one. It's a project that is well maintained, and we have a big community behind. Do you have any question regarding the manual testing approach before we move on to the automated one? Yes, sure. So this is one. Yeah, good question. Thanks for asking this one. Actually, um, you can in order to configure a browser to proxify traffic to Burp Suite, it depends on the browser you are using. Okay, so let's suppose, and this is explained on the documentation of Burp Suite. So for example, if you are under Mozilla, Burp Suite, Mozilla proxy. So for each technology, you have a guideline on their website on how to configure the proxy settings. Okay, so but basically there are two steps. The first one is you need to specify the IP address of your proxy, okay? And then you need to install Burp Suite certificates, okay? This way you can intercept or decrypt the HTTPS traffic if your API is using HTTPS. So the certificates can be exported using this menu. So it's under proxy setting, and then you have import certificates, okay? But if you don't want to use your own browser or the one that comes by default in your machine, Burp Suite now, or since a few versions, they have a Chromium browser embedded directly in Burp. So it comes prepackaged within Burp Suite, and you can use it right on. You don't need to install or configure anything on the browser. It will automatically proxify the traffic to Burp Suite. So in order to run this browser, we have under proxy intercepts open browser, and it will open up the Chromium, and then each request you input here, it will be sent to the browser. Okay, so this it actually simplify a lot the process of setting up the environment if you want to use Burp to assess your application. Any other question? Or shall we move on with? Okay, so now we saw how the security. Why is a rooted device or emulator required? Emulator required for Android. Yeah, another interesting question. If, for example, you want, I guess the goal here is to test the API used by a mobile application installed on, or the Android version of your mobile application. We need a rooted device because it's much easier to change the proxy settings in order to proxify the traffic from a mobile application, an Android application, to Burp Suite. The process is a bit complex, and it depends on how your application implements HTTPS communication. For example, if you are using SSL pinning, it might be a bit harder. For iPhone, it's also a bit complicated. But yeah, that's the reason why we use a rooted device in order to simplify um, uh, the um, the setup of the proxy settings. Otherwise, it will be you cannot change the settings of your phone, and we need also to install the certificate. So let's suppose again that the Android application is invoking or consuming HTTPS API or API that use HTTPS secured version. So it's important to install the certificate provided by Burp. So this way you can decrypt and re-encrypt the traffic sent by the mobile application. Okay, perfect. Um, so let's move on to the next section. So the goal here is to see how we can automate this process. Okay, but first thing we need to consider is time. We don't have time to write tests. I guess all of you agree that writing tests is already a time-consuming issues, and if we do it, we need to do it at least for sensitive and critical functionalities. And generally speaking, we don't have much time to allow to write security tests, okay? And also it's a complex task as a developer, and this is my own opinion, and other security professional may not agree. I think or I believe that security topics we cannot push developers to have a full understanding or a full comprehension of security topics. It's, I think, a shared responsibility, but we cannot push, again, it's my own opinion, to be experts on security topics. So, but again, it's a common responsibility, and it's the role of cybersecurity professionals to provide developers and QA testers with tools that can simplify this process. So this way, as a developer, I don't need to be an expert about web application security testing. I don't need to learn by heart the ASVS document. I need just some tooling, some process that can simplify the process of it. Won't take much time, um, and this way I can focus on my real job, which is shipping codes and run test, for example. So this is the first constraint. We need to be easy as much as possible. I don't want to install or configure something on my machine. I need to be. I need it to be. The goal is to have a process that is transparent to the developers, and also in terms of integration, I don't need to change the whole way I'm doing my job as a developer or as a QA tester. I just need to extend my existing setup to integrate security testing. So this is the two main goals. Um, it must be a not consuming, time-consuming task, and also it needs to fit into my existing process. I don't need to change the way I work in order to do security testing and include it as a part of my job. So this is the two main challenges. Let's see how we can achieve this in practice, and I will explain through two different methods. Okay, so how to automate all of these security checks, or at least the most important security checks. So this way, I am sure that my API have certain acceptable level of security, and not and cannot be hacked or owned by let's say an entry-level hacker that have just saw some YouTube videos on how to pen test an API. So it would be a shame. So the goal here is to automate at least the most important one. And if we have time, we can also build up and extend our testing ability to cover more complex stuff. So the first thing or the first approach that we will use, I guess most of the API has a Swagger definition file. So the idea here is to import this Swagger file definition. Okay, and here, as you may notice, I don't have Burp anymore. I have another tool called Zap. So Zap is an open source security testing or attacking proxy. Okay, only open source. All right, and it has almost the same functionalities as Burp. So you can intercept the traffic, you can replay it and play with it. You can also run automated security scans. Okay, so that provide the ability to import Swagger or OpenAPI, for example, definition. So if we have, so inside this this file, we have a list of URLs. Okay, and also the API call structure and input for each endpoint. So Zap will map all these URLs, okay, or extract all these URLs and import it inside his own database. Okay, it's the same thing we did with Burp Suite, where we import or extract the list of URLs from the HTTP history. Okay, so this process can be done automatically, which is a big advantage. We don't need to navigate through the application or configure the proxy, etc. We just need to provide the Swagger file to our tool, and from there he will extract all the API calls that can be used later on to do the analysis. So first step is the import. Okay. Second step is the analysis using the imported URLs. And finally, we generate a security report. And this report contains all the details related to the vulnerability that has been identified. For example, for each endpoint, you have this and this issue, and also how to fix it and mitigate the risk. And this process is fully automated, okay? The entry point, or the only thing I need, is the Swagger file. And if it's an authenticated API, I need also to configure the authentication credentials. Okay, so this is the first approach that we can use. The only thing, again, we need is the Swagger file, and if it's an authenticated API, we need to have valid credentials as well. And the final result is a security report with all the details and issues that need to be fixed. So this would be the topic of the first lab. So I will put the link to the lab on the chat. Okay. Yes, it's the Open API document, but we can also import using an WSDL if it's a SOAP API, and also the GraphQL, it's also supported. So the three main formats that are commonly used are supported by ZAP. Okay, so can you just check if you, okay, does this apply only to RESTful API? No, it's yeah, the tool support both RESTful and also SOAP APIs. Okay, so can you just check and confirm if you have access to the link on the Instruct platform? So you just need to provide your information and the email address that you have used for the um, to subscribe to the workshop, and from there you will have access to a sandbox that you can play with just from your browser. Okay, and from there we will have two tasks, or two labs to perform. The first one will be related to using the Swagger file to run security tests. Okay. So I'm going to do the same, and don't hesitate to walk through with me during the same time. But you can also do it later on if you want to, because I have, since it's 2-3 hours workshop, we'll have enough time to conduct the labs. So the first step is, once you are there, is to start the lab. It would take around 2 minutes to set up the environment. And again, please let me know if you have any issue to start off the lab or in case you don't have access. It will be available only during the workshop session or slots. Also, I've put the slide decks on this Google Drive, so this way you can use it later on if you want. And I will share also the lab instructions in case you want only to focus on doing the lab. Okay, so the lab should be ready in few seconds. And again, we'll try to use Zap in order to import the Swagger file and automatically do all these steps, which is analyzing and finally generating the report. Okay. So just a few words about the lab environment. So here, basically, you have two main sections, and you can play with the size using this button. And here on the left, you have your sandbox. Okay, so it's basically a Ubuntu a virtual machine. You have root access, and inside we have some tools or some stuff that we will need to install later on. So we have Docker already installed. You can use it directly. And then target application that we will have to assess. So this is our target. It's a RESTful web application. But if you want, you can also test. There is also the SOAP version available. You can check it on the documentation. And then you have also web ID in case you want to modify or change stuff on this sandbox. Feel free to do so. It's temporary sandbox. It will expire automatically after 2 hours. So make sure if you want to take screenshots or save things before it expire. And each time you start the session, it will start from fresh and no data is saved. Okay, so this is the first section on the left. It contains the environment. So you can use it directly using your browser. And on the right, you have the lab instruction. Okay, so you have the list of the command that you need to input in order to run the security test, for example, and so on. And you can copy paste easily from the instruction session to the sandbox. And you have also the explanation of each step. Okay. So this is the two section labs. And you can check your progress. So here we are playing or are on the first section, which is testing with Swagger files. The next session section we will see together is using Postman. Okay. And also, if you want to completely hide the lab instruction, you just need to click here and it will completely disappear. So this way you can focus only on the sandbox CLI. Again, feel free to drop a message if you have an issue with the lab. Otherwise, we can start off, can do it together. So, and don't hesitate if you want to follow all along. And before this, I want just to provide some info about the ZAP tool. So ZAP again stands for Z attack proxy. And it's an open source version of Burp Suite. Okay, it's basically it offers the same functionalities, and you can use it to do manual security testing, but you also can use it to automate your security testing. Okay, we will use the default testing scripts, which are already enough to test most common issues like SQL injection, command injection, etc., etc. And there is also you can also write your own testing scripts, okay, and embed it inside this tool. The tool also comes with many extensions in case you find that the default functions are not enough. So these extensions are managed and maintained by the community, and it allows you to go deeper on your testing approach. Okay. So in our case, the tool, another important point, the tool comes with two, you can use it in two ways. The first way is using the graphical user interface. So it's a bit similar to Burp Suite. But you can also use it with the headless mode. So the same tool is prepackaged in a Docker or in a container image, and you can execute it again using the headless mode. And this way you can automate if you want your security testing. Okay. Perfect. Now let's go back to our lab environment. And here is the process is very simple. Again, the input is the Swagger file definition. Okay. You can either use a Swagger file that is available on the target application itself, like this example, or you can store this Swagger file or this Open API definition locally, and then Zap will be able to import it. Okay. Either way works totally fine for Zap. Then we will use, in order to automate all these steps, which is importing the URLs, running the analysis, and generating the report. We will use a Python script that is prepackaged within the container image. It's called Zap API scan. And this script will help us to automate the whole process from importing to analyzing to generating the reports. And as you can see here, we have support to many formats, OpenAPI, SOAP, or GraphQL. We can either import the API definition from a URL or locally from the local machine. Okay, and regarding the reporting, we have many ways to export or many format to export the reports. We have HTML, we have XML, JSON file, etc. So this way, if you want to integrate the output of the scripts or this process into, let's say, create Jira tickets or push it to a database or whatever, the tool offers much flexibility in terms of reporting. And this is by so far one of the best tool to do automated security testing, and it's even way better than commercial tools because as you know, commercial tools are like a black box. You don't know what is happening inside. They have limited API documentation. You cannot automate all the stuff. But with this open source tool that is designed for security testing, you have much flexibility and you can do a lot of things. And this way you can embed it on any CI/CD engine or any testing tool. Okay. Again, all these, so the scripts will consume the API exposed by ZAP. Okay, so it allows us to automate the full process. And at the end, we will have a nice, beautiful report that contains the result of the scan. Okay. So in this command, we have many parameter. I will go through the most or even all of them. So this is the ZAP API scan. So here we specify the format, which is OpenAPI. The report will be saved to this file using HTML format, which is the default one. And here we specify the OpenAPI definition using this URL. Okay. The -d option is just to run the script in debug mode. So this way we can see all the stuff that is happening behind the scene. Okay. This by default will run an authenticated scan, but if your API support authentication, and here we have no limits depending on how you your API or how authentication is managed by your API, you can automate it and use it as a part of this step or before executing the scan. So here we are taking a simple example where the authentication is done using a GWT token, which is provided as a bearer token. Okay. So this on-var is to specify the value, and this one is to specify the name of the header. Okay. This will tell ZAP to use these headers, these two headers, whenever he wants to call an API or a URL inside this API definition. Okay, and that's it. We using all these settings, we are ready to kick off the scan. As you can see, it's very, very simple. Since we have the Swagger definition and the authentication is handled simply by the tool, we are ready to kick off the process. Okay. So the first time you run this command, of course, you will need to download the container image. Okay. And once it's done, it will kick off the scanning process using the ZAP API scan scripts. So at this point, we just need to chill and relax. And of course, we don't scan production, especially on Friday. Otherwise, we stay for the weekend. But important things. This is a runtime analysis, which means that the tool will send HTTP requests, and behind it may execute SQL commands or stuff like that. So it's very, very important to run this scan, especially when it's when it's authenticated on a non-production environment. Okay, you can run it even on a local version of your application, but never run this kind of tool on the production, because we cannot guarantee the outcomes of what will happen when using this kind of tool. Okay, so this API or this script, as you may notice on the output, we have already import the URLs from this OpenAPI definition. And as you can see here, we were able to import all the URLs mentioned on this Swagger file. And here we will use scanning policy called API minimal. So this API minimal contains the list of checks that are relevant only to API, because again, this tool can be used to scan or analyze web application. Okay, but some security checks or some vulnerabilities doesn't make sense for API. Like for example, cross-site scripting, which is injecting JavaScript into the HTML front. So in case of an API, it doesn't make sense to test this type of issue. So this policy contains the list of checks that are only relevant to when testing an API. Okay, but you can customize this policy if you want to. The details are available on the documentation. Okay, then we are now at the scanning phase, which is this one. Okay, so we have finished the import. We move now to the analysis. And depending on the size of your application and the number of endpoints available, it will take some time. Okay, so now I will open up just a few remarks on the performance question. If it's as you can see here, we have full control of the list of target and endpoint that we want to scan. Okay, so depending on your process, if you just have one endpoint or new changes on a specific endpoint, sometimes it's not necessary to rescan the whole thing. Okay, simply because if you have 1,000 endpoints and you import all the OpenAPI definition, it will definitely take some time. So you may want to, for example, if you want to push a new release, you can limit the scope of testing only to specific URLs. So this way you can accelerate the security check step. So let's suppose you want to embed these scripts into your CI/CD pipeline. For example, we have a step which is build, tests, and then push to production. And we want to add the step before the push to production or push to a pre-prod, where we run this script. Let's call it a security test. You have full control of the scope of testing. So you can limit only to specific URLs. Okay, but it's also important to do full scans from time to time. What is recommended is to have, for example, a weekly job that will import the whole Open API definition and then run automated scan on the whole endpoint. So this way, we have full visibility, and it can be a separate process. You don't need to put it on the CI. It can be automated using any tool you want, and this way you will not slow down, for example, a CI/CD pipeline or stuff like that. Okay. So the scan is still ongoing, but I have the final reports, or the sample reports of the scan. So let's see how it looks like. So in the first section here, I have the report on HTML format. And here we have a brief summary of how many issue or how many vulnerability has been detected. They are sorted by type of risk or level of risk. So here, for example, we have 2 issues with high risk. By reading the details, they are really important. So the first one is a remote with command injection and also SQL injection. We also have some medium and low informational issue. One nice thing about this script, it will generate different exit code depending on the issue that has been identified. Okay, so it will return 1 if there is at least one control that has failed. For example, you have told that to check if there is no SQL injection. Okay, so if in this case we have a SQL injection, this script will return this exit code. Okay, so if you run this inside your CI/CD engine, it will fail the step that excuse me. So it will fail the step that uh, executes the scan. So this way it will prevent going further to the other steps, which they are, for example, deploying to pre-prod or to other environments. So the script again is for multiple way to integrate this inside your CI/CD engine, and again. Depending on your technology, you will need to tweak or change some stuff, but the main step are already automated, or the important one are already automated in this script. Okay. Perfect. So let's go back to the reports again. For each type of issue has the number of um, similar issue, and if we click on the details, we have an explanation of the issue, where it was identified. So here the vulnerable endpoint is this one, and the parameter is vulnerable parameter is post ID. Okay, so this gives me enough information to go and check my code in order to fix the SQL injection, and I think that's it. The solution, well, this one is very important. For each issue, not only you have the details of the vulnerability, but also how to fix it. Okay, and then you have some links and references to the OWASP community, so you can use it to speed up the remediation process. Any question, remarks? Before we move on to the second way to automate security testing for API. Okay, I will give you 8 minutes. I'm not ready to this, but will be recording. And um, yes, I think there would be a recording, but yeah, we need to check this with the organization community. And for the report, it will be saved to your local environment. Okay, if I go back to, normally it will appear here at the root file. Okay, so it's in an HTML file. You need to copy it from here and then download it to your machine, copy it to your machine. Okay, any other question? Okay, so in 7 minutes, I will move on to the next part in case some of you want to test this on the sandbox environment. Okay. Another question. Guide to write custom scanners Python files. Yes, this will be the subject of the next section. And so this is the Python implementation to access Zap API. Okay. I will also provide you with Zap API scan source code. Okay, another question before we move on to the next section. Okay, so this was the first approach, which consists of using the Swagger file, like the OpenAPI definition, to import URLs, and from there, Zap will take on the process and provide us with the security reports. Okay. The next approach is quite similar, but we'll use a different tool or a different approach. But before we move into to this approach, the limitation of the using only the Swagger file is we have the URLs, we have the name of the parameters, but we don't have sample data like this, like what we have had here in Burp Suite, for example. So I don't have, I only have again the name, the list of URLs, the name of the parameter, but I don't know what kind of data I need to, or what sample data I need to input here. Okay, so I don't know if it's I need to provide a valid email address, a valid name, etc., etc. So even if I have the list of URLs or the list of the parameters, I cannot guess by myself, or especially when doing automated scans, what are the valid data that I need to input in order to be able to interact with this API. So let's suppose, for example, there is input validation on this API. So if I don't have invalid input, I cannot go deeper on my analysis, and this will stop me at the first uh, steps, and I cannot see what is behind this API. So imagine if there is calls to external APIs, or calls to external functions, it can be difficult to go deeper in case we are only relying on a Swagger file. So this is the first limitation. Second limitation is sometimes we don't document all the APIs, and this is very common. So we may have some, we may miss out some spot or some endpoint. So this is what we call shadow APIs, which means API that are available on production or the runtime environments, but they are not documented. And if they are not documented, we will not be able to figure them out by ourselves, especially when running automated security scans. And that's why using a Postman collection can be more useful, because not only we have the list of URLs, okay, and the name of the parameter, but also some sample data. So this way, we can have simulate live interaction with with the API, and use this traffic in order to test, or at least have some sample data that we can use on the second and third step to do our assessment. So the goal here will be is to, first, we are going to will not import automatically the Postman definition. It's a feature available by Zap, but it's not tested yet. It's still a new feature. What we will do is quite similar to what we have done at the beginning of this session. So we have a Postman collection, which is a JSON file. We will use Newman in order to execute this collection, okay? This will import API calls, not only URLs, but also API calls to Zap. How we will import these API calls? By simply pointing or using Zap as a proxy for our CLI command Newman. Okay, so instead of sending the HTTP request directly to the API, we'll use a parameter called HTTP proxy, and inside we'll tell Newman to send the traffic to our Zap instance, which let's suppose running on local host 8080. Okay, and then Zap will use this traffic. So this is the first step. Zap will use this traffic to do the scan, okay, and finally generates the reports. Okay, we'll try to do the same thing, but now without using the OpenAPI scanning scripts that we used here in the first section of the lab. I will go back to the lab environment. So here we, as I said, we used these scripts, and this one did a lot of stuff behind the scene. In the next section, we'll break down each step done by the scripts. We will directly use this API or the API Python implementation that consume Zap API in order to automate the whole process. Okay, again, same structure, same stuff. You have on the right the lab instruction and then your environment. And now we have a different web application. It's capital 1. And you can test the application again by creating your account, etc., etc. So for this, so this web application behind the scene consume an API located at API. Okay. And let me see if we have the documentation here. Yeah, this is the documentation of the API that we want to test. We have the Swagger file already available, but we will not use it. We will use a Postman collection that I showed before here. Okay, but we will not execute this Postman collection using the GUI. We will use Newman to execute it. Okay, so first step, we need to have our Zap instance up and running. Okay, this way we can use it to act as a proxy and do the security assessment. So first, let's start Zap instance on our local machine. Here I did start on the local host, and it will listen on this port. You can also enable authentication if you want. So let's suppose you host Zap on a dedicated server and you want to configure authentication for the API. You can achieve it by doing so. You can also limit the IP address source that will use the Zap API. And through the Zap API, we can automate the whole process, which is importing the API definition. For example, we can trigger the scan and then exporting the scanning results to an external file, either using JSON, XML, or HTML format. So here I have my Docker instance up and running. The first one is from the first section of the lab. Here we will use this instance instead. Okay. So as we said before, first step is we need to import the API calls or inject or proxify these API calls through our Zap proxy. This can be automatically done when running your when testing your API using Postman collection. So let's suppose that you use Newman as a step inside your CI/CD. The only thing you need to do or you need to add to the step so we can import traffic to Zap is this envar. Okay, this will instruct Newman command to proxify all the traffic to our Zap instance. Okay, let's do that and see the results. The Postman collection is available locally on your sandbox. Okay, you don't need to download it, it's already there. So here I'm running as usual my test using Newman along with the Postman collection, and the test looks almost fine. I have the report of Newman. Okay, so now let's check what happened on Zap. And in order to interact with our Zap instance, we will use the Python client that simplify how we interact with our Zap instance. So let's open a Python console and import the Python SDK library. First thing you need to configure is how to connect or interact with your Zap instance. So here in our example, it's running on the ports for both HTTP and HTTPS. And here is the targets that we want to scan. Okay, I will start first, but by just checking how much URLs are available on Zap side. And here, as you can see, I have so here I have the list of all the URLs that has been triggered by my Newman test command, okay? And they are already available in the history of Zap, so I can use them right away to do my security scan. This is almost the same thing when we check on the graphical user interface to view the list of API calls. So instead, we are doing it automatically using the Newman command, and then we check the results with the Zap API. Okay. One additional thing, and now it's another level of testing of security testing. Let's suppose that you are worried about the fact that you may miss out some API in your Postman collection, okay? You don't have all the API tests inside your Postman collection. You can always do, you can use a process called spidering, which will try to identify more URLs in your application. So let's try to do this and see the results. I would just change a small thing here. So the spidering process again will try to identify more URLs. So this way, if we have a missing stuff inside our Postman collection, Zap will try to guess it and identify it. So here the spidering process has been already start off. We can check um, the status using this method. Okay, let's check again the number of. So here we had like. Let's see if the app was able to identify more URLs. Tech. Okay, perfect. So as you can see here we have only the URLs that has been called during the Newman 1 command. Okay, but after doing the spidering using Zap, we were able to identify more, which is really interesting because this way we have more coverage in terms of scope. Okay. And this way, again, we will make sure that we will at least we will maximize the number or the chances that we will identify security issues in our target API. Okay, perfect. So if I go back again to the initial methodology that we have discussed at the beginning, which is recon, endpoint analysis, exploit, and own. So the reconnaissance, again, the goal is to identify the list of URLs. This is what we have done. Okay. Now we will start off, we move on to the next two part, which are endpoint analysis and detection and exploit of issues. Okay. Before we kick off the scan, we need to specify the scan policy. Okay. The good thing is Zap comes with pre-configured scanning policy, okay, that you can use directly, but you are free to define your own scanning policy. So for this lab, we will only use the default ones, okay? The policy that we will use is the API minimal and tech. This will automatically kick off the scanning process. Okay, you can always check the um, scan scan ID. Okay, so this will can be used to check the status of the scan or the ongoing scan. Once it's finished, the next step is reporting. Okay, and again here we have different formats under which we can export the results. Okay, here by calling alerts, it will generate the list of issue that has been identified. Okay, so here, for example, if I do alerts in think can use name. Okay, So again, we have the list of all the issue that has been identified during our scan. It's still ongoing. I think tech, yeah. And if you want to export the reports using the HTML formats, you can just call this function and then it will export the results. You can store out the variable and then uh, send it or share it using any way you want to. You can also export using XML format or JSON format. Okay, so as you may notice, we didn't change anything on the way that the tests, that an existing test is done. The only change or minor change is we did proxify the traffic to our ZAP instance, and from there we use the same traffic to do the security scans. We did also the spidering in order to discover more. So this way, if we have something that has been missed out, that it is not mentioned on the Postman collection, we can always scan it. And we used the default scanning policy called API minimal, which focus only on things related to API security. You can also create custom ones. And after, once the scan is finished, you can export the alerts to under different format, either HTML, JSON, or XML. Okay, any question regarding this second approach? Otherwise, I will give you some few minutes to complete both labs in case you would love to, and then we will finish by the conclusion. Okay? Yes, I have a question. Is any risk doing this? For example, you mentioned, yeah, it's important to do this on non-production environments, and yeah, it's you need also have an authorization or permission to perform the test. So there is an agreement between the two party, but if you are the owner of the application, you can do a security assessment right away. But the important why this is necessary because simply because these are the same tools or the same type of tool that are used by attackers. They don't do manual or static analysis. They don't do dependency check or stuff like that. They do automated runtime checks. Okay. So the only thing that they do have is your application or the target API, and then they use the same tools. Unfortunately, ZAP is not only used by security professionals, but also by hackers. They use the same tool to do security as checks. Okay, so in order to challenge your API to a real world situation, it's important to do this kind of tests. Otherwise, you don't have assurance that your API is fully secured against automated attacks. And generally speaking, we have two types of attacks: targeted attacks and automated attacks. Automated attacks usually will scan the whole internet, and if there is any vulnerable uh, websites, they will even exploit them automatically. Okay, and targeted attacks is more complicated, more sophisticated, because they involve manual assessments, and they focus only on a specific target. But if you compare uh, the um, the amount of or the number of attacks or automated attacks compared to targeted attacks, usually um, 90 or 95% of the attacks are done automatically. Okay, so it's important to be able to reproduce this type of attacks, because if so, we already cover a huge part of where the risk may came from. Okay. Okay, so I'll let you continue with the lab, and we will move on to the conclusion at in, say, in 10 minutes. Okay. Managed to complete the other steps of the lab. So what I suggest is to move on to the conclusion. Okay. I'm sharing my screen. Perfect. Um, as you can see, the process is straightforward. It can be easily integrated into existing tooling. Okay, but it comes with some limitations. It's important to keep them in mind. First one is we are not testing the business logic issues. For example, um, these are the most complex one to identify and test using automated tools, simply because it involve um, first having knowledge of or an understanding of the nature of each API and how it can be used. And it also and sometimes require combining or chaining multiple API calls. So for a simple automated scanning tool, this is bit difficult to detect. And here the goal again is to cover only the most important technical issues and not one related to the business logic of the issue of the API. Second drawback of this approach is depending on the size of the application or the number of the endpoint that you need to analyze, it can take too much time. Okay, I don't have exact numbers, but you can do the experiment by yourself and see how much time your CI/CD or your local machine will take to scan your whole API. Okay, and third limitation is we may miss complex vulnerabilities. Again, it's very close to logic business, but these are issues that need to manual test or manual analysis in order to detect them. Okay, and last point is we are always limited to the information that are available on either the Postman collection or the Swagger file. So if there are any missing endpoints, we won't be able to test them using SEP, and this so we depend on the coverage of your or the existing integrations test. So if you have good integration test coverage, this will help you also to have a good security coverage. But it's still important for many reasons. And I think we already discussed the first one is these tools are already used by attackers. So I don't see any reason for not reusing them because they are the most realistic and effective way to challenge your API, which means if your API already contains classic or technical issues, this is really problematic because anyone with the same tool can and will be able to detect and exploit these vulnerabilities, as we show as we have seen together in the reports. So before going to complex issues or complex business logic vulnerabilities, first we need to at least cover the technical issue or the one that can be easily detected by automated tool. And second point is we don't need access to the source code. Okay, so unlike static analysis where you need to have the source code of all the components of your application. So suppose we are on microservice architecture, and usually we have different components split on different Git repository. In order to grab all the Git repository and scan them at once in order to detect security issue, it can be very complex, but using a runtime application or runtime, the runtime of the application with and executing the ZAP scan. This way, we can directly start the assessment. And a last point is the integration with the CI/CD. As you notice, everything that can be done on the graphical user interface of ZAP can also be done using the API of ZAP. And you have a Python script that can automate the whole process. So it can be a good starting point to build your own security testing script that will fit in your existing process. And this will can be integrated on any CI/CD engine. The only prerequisite is to have a sub instance and Python environment or a container to interact or execute your automation script. And you can even run it locally. Let's suppose you have a working environment or a dev environment in your local machine. You can test it automatically using ZAP, or use your integration tests, your Postman collection, and combine it with ZAP in order to test on the same time functional tests or do functional tests along with security testing. So that's it on my side. I don't know if you have any other question. Okay, perfect. Just one last slide. So this was the short version of my API security training. I do also provide many other security training. I've mentioned only 3 on this slide. I have the web application security training. It can be on 1 or 2 days. I have also the identity and access management with OAuth. So the goal is to see how to use this protocol for both identity with OEDC and also authorization management. And that's not pretty all. Again, my name is Abdessamad or Abdi. I was very happy to provide this workshop, and I'm looking forward to participate in the upcoming editions.